Welcome to Study Loop.
Okay, so all the conditions of the previous problems are the same, except other than rotating around a fixed center, the disk rolls without slipping on the horizontal surface. If the disk has a clockwise angular velocity of 20 rads per second and an angular acceleration of radians per second squared, determine the velocity and acceleration of pin A relative to the slotted member BC and the angular velocity and acceleration of BC. R is equal to 200 millimeters, and we're told to neglect the distance from the center of pin A to the edge of the disk. Okay, so we're going to draw a diagram of the system to figure out angle B. So let me go ahead and I'm going to draw my diagram on this page. So here will be B, here will be A, this will be my origin. Okay, so this is Y, and this is X. And let's see here. Let's extend this and extend this. This will be angle beta, and this will be angle beta. I believe that this one is 60 degrees, and this will be 60 degrees. Okay, and then let's start. We're going to do the laws of sines to calculate the angle. Let's begin. 180 minus beta plus 60 r over the sine of beta. Okay, and let's this be equal to 3. Can take an r out of each side, sine. This will be 120. And now we'll have this times the cosine of negative beta plus the sine of negative beta times the cosine of 120. Okay, and now this we can further reduce a little bit here. This will be the sine of 60 times the, oops, let's get my parenthesis in a better spot there. Minus the cosine of 60. Okay. Then this can go to be plus the cosine of 60 times the sine of beta. Okay, getting close here. This will equal the sine of 60 cosine of beta, and Now we're at the tangent of beta equals the sine of 60 degrees over 3 minus the cosine of 60 degrees. And now we've got beta equals tangent to the minus 1 of the sine of 60 degrees, and this is solvable now. And this will equal 19.1 degrees. Okay, and then we can calculate the distance BA. Let's switch colors. Again, law of sines. It'll be R over the sine of 19.1 degrees. And this will be BA equal the sine of 60 degrees over the sine of 19 degrees times 0.200, which will equal 0.5293 meters. And now we can write the velocity at A, we'll call that VA, with respect to B, in terms of VB, which is equal to 0. The angular velocity of the slotted member, and we'll reference that as the relative velocity of A with respect to B. And that'll be V relative. And RBA is the position vector from B to A. Okay, so VA will equal VB plus my angular BC. That'll be plus V relative. This is equal to 0. So now we'll have VA will be equal to, this is 50 times 0.5293, I'll leave my units off, times the cosine of 19.1 degrees I plus the sine of 19.1 degrees J, and that's this part, plus my V relative times the cosine of 19.1 degrees I plus the sine of 19.1 degrees J. Oh, wait. No, that's right. And this will equal, I'm not sure I can get this on here. I'm going to go to my next page. This will equal 0.5293 times the cosine of 19.1 degrees minus 0.5293 times the sine of 19.1 degrees WBC I plus the cosine of 19.1 the sine of 19.1 degrees. That was I of V relative J. And then we can get VA with respect to O. Switching colors for this. Okay, so here I've got VA, and this will equal 20 times 0.200I plus negative 20K times 0.200 times negative 20K times negative 0.2000200. Then I'm going to take this times the cosine of 60 degrees I plus sine of 60 degrees J. And the two definitions of VA need to be equal. So let me keep going on this one. 4I plus 4 times the cosine of 60 degrees J plus 4 times the sine of 60 degrees I. So these have to be equal. So let's write these out. I'm going to get two systems of two equations. My first equation. I'm going to have here's first, and then we've got okay, and then my second set equations. If we can solve these two systems of equations. We will get our WBC 1.044 radians per second clockwise, and our V be 7.07 meters per second at an angle of 19.1 degrees. Okay. Then we've got our first bond. Now we're going to find the acceleration vector in terms of AB, which is equal to 0, and the angular acceleration. Okay, and of the relative to the acceleration. So angular acceleration will be equal to AB and that'll be plus plus and now we can get, since this one's equal to 0, we'll get this okay plus still solving here, just trying to minimize my talking so I don't make dumb mistakes. Okay, that plus take that times and okay. And then this will equal, this is a long one, I'm still here. And keep going. This is continuing. I think I'll continue this here. I think I wrote this wrong. This should be 707. Okay. Times the sine. Okay, done with this equation. And we can also obtain our acceleration with respect to O. Okay, this will equal -5 times 0.200I plus 5K times 0.200. Then I will have negative cosine 60 degrees I plus sine of 60 degrees J plus negative 20K times negative 20K times 0.200 times negative cosine 60 degrees I plus sine of 60 degrees J. And this will equal negative I J. This will minus the sine of 60 degrees I plus 0.200 times 20 squared times the cosine of 60 degrees I minus 0.200 20 times the sine of 60 degrees J. And we get two equations again. So my two equations will be equal to, I'm going to switch colors. There, got that one on there. Um, okay, equals that. And then I've got minus times the sine of 19 times a relative. My other equation is and okay, very good. We can solve these and we'll get the following. Solve these two and we'll solve and we'll get alpha BC and our relative will equal and 13.78 meters per second squared at an angle of 19.1 degrees. Oh, good.